All right, welcome everyone. Today, we're going to put on our detective hats and investigate one of the trickiest mysteries in all of statistics, the case of the missing data. I mean, what happens when the very evidence you need to find the truth just, poof, vanishes? And how do we, as statistical detectives, piece together the whole story from a bunch of incomplete clues? Let's start our investigation.
You know, this isn't just some academic question. It's the real core problem of what we call non-response. And it's a huge challenge that can totally undermine any survey or study you're trying to do. See, when the people we pick for a sample just don't respond, we're left with this gap. And filling that gap the right way, well, that's the difference between a rock-solid conclusion and one that's just plain wrong. So, here's our game plan for this investigation. First, we'll survey the crime scene. We'll figure out what missing data even means. Then we'll ID our prime suspect, which is bias, and see exactly how it messes with our work. After that, we'll open up the investigator's toolkit and look at the methods we have to fight back. We're going to do a deep dive on one really powerful tool called two-phase sampling. Then, like any good detective, we'll try to uncover the motive. Why did the data go missing? And finally, we'll deliver the final verdict on when we can crack the case and when we might be stuck.
Okay, let's start by defining our terms. In the world of statistics, missing data isn't just one single problem. It really breaks down into two main categories.
The first type is what we call unit non-response. This is when an entire person or an entire household gives you nothing, zero information. Think of it like their whole file is just gone from the filing cabinet. The second type is item non-response. This one's a bit sneakier. We have the file, but when we open it, some of the pages are blank. The person answered some questions, but then skipped others. Maybe the tricky ones about their income or health. For today, we're really going to focus on that first one, unit non-response, where the whole file is just gone.
To really get a feel for how big this problem can be, let's move away from the abstract and look at a real-world scenario. Because, numbers have a funny way of making the stakes crystal clear.
So imagine we set out to survey 10,000 households. Right off the bat, we find 1,000 of them are ineligible. Maybe they're vacant lots or businesses that shouldn't have been on our list. So out of the 9,000 that are left, we just can't get in touch with 700 of them. For another 200, we can't even figure out if they're eligible. And then a full 1,400 households, they just straight up refuse to participate. Every single one of these is a different path to the same problem, missing data.
So how do we measure this gap? Well, we use something called the non-response rate. The logic here is actually pretty simple. The numerator is all the people we missed, the refusals, the no contacts, and we throw in those unresolved cases just to be safe. And the denominator is our total sample, minus the ones who were never supposed to be in it in the first place, the ineligibles. This gives us the percentage of our real, valid sample that just disappeared.
And when we plug in the numbers from our example, that's 2,300 people we missed out of a valid sample of 9,000. That gives us a non-response rate of over 25%. A full quarter of our data gone before we even start analyzing anything. This isn't just a small problem. It's a huge hole in our evidence. And that brings us to our prime suspect.
You see, the real reason a 25% non-response rate is so terrifying isn't just because our sample size got smaller. No, the real danger, the prime suspect that can poison the entire investigation, is bias.
To really get bias, you have to think about our population as being secretly split into two groups. There's the group of people who would respond if we asked them, and then there's the group of people who just wouldn't. And in theory, each of these groups has its own size and its own true average for whatever we're measuring, like income. And right here, this is the heart of the problem. What if the people who talk to us are fundamentally different from the people who don't? If their stories are different, then any conclusion we draw just from the respondents is going to be skewed. It's a distorted picture of what's really going on in the whole population.
In fact, we can get super specific and write this down as a formula. This equation right here, this is like the smoking gun in our case. It tells us that the bias in our sample estimate is basically two things multiplied together. Let's take a closer look.
So this formula has two key parts. The first part is just the non-response rate. That tells us the scale of our problem. Is it a tiny little issue or a massive one? The second part, that's the difference between the story we have from the respondents and the story we're missing from the non-respondents. The total bias is just the size of the problem multiplied by how different those two stories are.
And this leads us to a really powerful insight. The bias is only going to be small if one of two things is true. Either the non-response rate is tiny, or the people who responded are almost exactly the same as the people who didn't. And here's the kicker. We can never really know if that second part is true because we don't have their data. So the only thing we can really control as researchers is trying to keep that non-response rate as low as possible.
Okay, so we've defined the crime and we've identified our prime suspect, bias. So what do we do? How do we fight back? Well, luckily for us, we've got a whole toolkit of methods to deal with non-response. There are basically 4 main strategies. The first, and hands down the best, is to prevent it from happening in the first place. That means better survey design, better training, maybe offering incentives. The second is to actually subsample the people who didn't respond and make a really intensive effort to get their data. Third, we can use fancy statistical models to try and predict what the missing answers might have been. And then there's the fourth option. Just ignore it. Now, obviously, this is a terrible idea, but it happens more than you'd think. It's basically just assuming the non-respondents are exactly like the respondents, which is a huge, risky leap of faith.
Let's just focus on that first approach for a second, prevention. As you can see from this diagram, it's not just one thing. It's this whole combination of factors: the design of the survey, how well your interviewers are trained, understanding what actually motivates people to respond. Getting all of this right is the absolute best way to keep that non-response rate down. Okay, now I want to do a deep dive on that second tool from our kit because it's a really clever and powerful statistical idea. It's called two-phase sampling, or sometimes you'll hear it called double sampling. So here's the logic. After your first attempt at the survey, you've got your 2 groups, respondents and non-respondents. Instead of just giving up on the non-respondents, you treat them like a brand new population. Then you take a random sample from that group and you throw everything you've got at them, your best interviewers, more money, whatever it takes. The goal is to get a small but hopefully representative sample of that silent group. And the beauty of this whole thing is that it lets us create a brand new combined estimate. We're not just relying on the people who answered the first time anymore. We now have this new piece of evidence that we can weave in to create a single, much more accurate picture of reality. And this is what that new estimator looks like. Now, don't get hung up on the symbols here. The logic is what's important. It's really just a weighted average. It takes the average from our original respondents and the average from our new subsample of non-respondents, and it blends them together. Let's look a little closer. The formula weights each group's average by how big that group was in the original sample. So if non-respondents made up, say, 25% of our original sample, then the information we get from them contributes 25% to our final combined estimate. It's a really smart way to stitch all our evidence together.
And here's the big payoff. If you can actually pull this off and get a high response rate in that second phase, it does 2 amazing things. First, it can pretty much wipe out the original non-response bias because you're now actually representing that non-respondent group. And second, it lets you calculate your variance correctly. It's a more complicated formula, but the result is a much more honest measure of your uncertainty. We're not just getting closer to the truth, we're also being real about how sure we are.
So far, we've mostly talked about the consequences of missing data. But a good detective always has to ask why. What's the motive here? In statistics, we call these the mechanisms for non-response. And there are 3 main culprits we need to investigate. Now, to get a handle on these mechanisms, we need a new idea: the response propensity. All this is, for any person I in our sample, is their theoretical probability of responding. The whole mystery of non-response really just boils down to figuring out what things are influencing this probability. Okay, first up is MCAR, or missing completely at random. In this case, the motive is just pure chance. The reason the data is missing has nothing to do with the person or the answer they would have given. The classic example is a lab tech who accidentally drops a test tube. That data point is gone for a reason that has nothing to do with what was in the tube. If this is the case, our respondents are still a perfectly good random sample, but let's be honest, this almost never happens in real surveys.
All right, next up is MAR, or missing at random. Now listen closely because this is probably the most misleading name in all of statistics. The data is not missing randomly. What it means is that the probability of responding depends on other information we have collected, but not on the missing answer itself. So for example, maybe response rates are lower for young men than for older women. We know the age and gender for everyone. If, within the group of young men, the chance of responding is the same whether you were a crime victim or not, then the data is considered MAR. And the third and toughest mechanism is NMR,
not missing at random. Here, the motive is the secret itself. The probability of someone responding is directly tied to the answer they would have given. So in our crime survey, this would mean that people who were victims of a crime are less likely to respond precisely because they were victims. The very thing we want to measure is what's causing the data to go missing.
Okay, this brings us to the final verdict of our investigation. Based on the motive we've just uncovered, we can basically classify the whole case as either solvable with the data we have, or, well, not.
So the way it breaks down is that both MCAR and MAR are considered ignorable types of non-response. NMAR, on the other hand, is non-ignorable. But it is so important that we understand what that word ignorable actually means here. Let me be crystal clear about this. Ignorable does not mean you can just ignore the missing data. Not at all. It's a technical term. It means the reason that the data is missing can be explained or modeled using other information that you do have. And because of that, you can use statistical tools like weighting to adjust for the non-response and still get an unbiased answer.
So here it is, our final conclusion. If the non-response is ignorable, if it's MCAR or MAR, it means we have the clues we need in our observed data to adjust our analysis and solve the case. But if the non-response is non-ignorable, if it's NMAR, we're in real trouble. The reason for the missing data is the very thing we're trying to find, and we can't fully correct for that bias using only the data we have. The case, in a sense, remains unsolved. And that really is the ultimate takeaway from this whole investigation. It's a question you should carry with you from now on. The next time you see a poll or read a study or hear some claim that's based on data, just stop and ask yourself, who's missing? Who isn't represented here? What's the story that we aren't hearing? Because sometimes understanding what isn't there is even more important than understanding what is. Thanks for joining me.